So the next what we are going to do is we are going to store the values of this array of this tree inside an array. So that is what we want to do. Okay. So let's look at the binary search tree, and we already know that if we do an in-order traversal, it'll basically have our array in a sorted manner. So what I want to do is I want to take this array, take this tree, and then traverse it in order, and keep storing the values inside this. Keep storing the values so that basically we can actually get the values inside the array. So that is what we want to do. The problem with that is, so what we can do is we can actually have an array. So this is of size 9, I think. So we can actually create an array of size 9. So I think that is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So what we will do is we'll traverse this, and we'll actually have a pointer. So the pointer basically points at the 0th location. So the pointer will first be at 0. When we add the value, we'll actually add 1, and then we'll increment the pointer value. And then we actually continue to do that. But the thing is, if we actually go inside this in order and we actually pass a pointer value, basically in the recursion, when it comes back, the pointer basically will go back to the 0th one and stuff like that. So we actually have to figure out a way in which we can keep the pointer value and keep incrementing the pointer value. In C sharp, it is easy. We basically pass the value as a reference. So when we pass a value as a reference, what happens is the function which is getting called always have the reference to the original one. But over here, they are actually in Java, you actually have to, all the values are passed by values. All the values that are passed inside a function is passed by value. So for that, what we need to do is we need to actually holding, create a holding like a data structure which holds an integer value, and then we will actually just pass that value and keep incrementing the value of that one. So let's see how we can do that. So what we'll do is we'll create new class, and we'll say this is int store. Right, so this is a value where we actually saving the value, and we'll say public integer, and we'll say value. Will not have a value of this, and we'll say private int store, and so that nobody can instantiate it, and we'll say public int store, which will have integer value, and we'll say this dot value is equal to value. And you'll see how we are actually going to use this one. Okay, so the function that we want to do is we want to write over here is we want to get the value, or store all the values inside an array. So I don't know, like we'll probably, okay, let's do this. So we'll say public integer, we are returning an integer array, and that integer array is so that's an integer array, and we'll say get store values in array. Okay, and store values, or yeah, that sounds good. So first thing that we want to do is we want to actually figure out what's the array size. So we'll say integer size is equal to get size, or size. So we'll get the size of our we'll get the size of our tree which is there. Then we will actually create an integer array, is equal to new integer, and it will be of size. Okay, so we create that, and then we actually say int store. So we create an instance of int store called pointer, a new int store, and this will take 0. So initially it will point at the 0th location. Okay, and we'll return ARR. Okay, so that is good. Next, what we want to do is we'll actually say public void, and we'll say store values in array. And the things that we'll pass is we'll pass a node, and we'll pass the integer array, and we'll pass int store ptr. Okay, so that is what we are going to pass. Okay, so the first thing that we will do is we'll first check if node is equal to null. So in that case, we actually don't do anything, we just return. Okay, otherwise what we do is this is a simple in order traversal. So we will actually go this, and we'll say node.left comma ARR comma PTR. Okay, so we'll say that the PTR is there, and we'll keep passing. Then what we will do is we'll say ARR of PTR dot value would be equal to node.data. Okay, and then since this is in order, we'll actually call this, and we'll go to the right. Okay, before doing that, we actually want to increment the PTR value, because like we add the array location at the 0th location it is stored. Now we want to go to the first location, so we'll say PTR dot value plus plus. So we'll increment that value. Over the calls, we'll continue to pass the PTR, but internally the PTR value actually will keep getting incremented as we actually go through the loop. So that should return us a value, and what we'll do is we'll say this, and then we will say root comma ARR comma PTR, so PTR. Okay, so I think this should actually return us the value of the integer, and we'll come over here, and we will say we'll come over here and we'll say integer ARR is equal to bst dot store values in an array. So this should return us for each and integer I in ARR. So for each integer I in the ARR, what we are going to do is we are just going to print it out. So we are going to print the value, and we are going to print I, and then we'll do okay. So this should do it. So let's actually run. So basically this is just a in order traversal, because we are coming over here, or we can actually just do, we'll just write this: if node is not equal to null, then we go inside it, and we do this, which is same as the code for the in order traversal that we already wrote. Okay, so I think this should yeah, this is good. Okay, so I think this should work. Let's run this and see what happens. So we'll say run, and Okay, so this is 1 3 4. I think like I need to probably put uh, mm, so this is there in the main. I probably need to, yeah, plus I need to put um, comma in between. So I'll do that, and let's run this again. So 1 3 4 6 7 8 10 13 and 14, and we can see that this is in sorted order, so we actually have the array in there.